Hey guys, welcome back to day 36. We are talking about oxidation reduction reactions today. All right, so what are our oxidation reduction reactions? It's a great question, and let's dive right on in. All right, first, there are two principal types of chemical reactions. The first one is acid-base. Acid-base reactions. You can think of this as proton, like the Bronsted-Lowry, transfer, or H plus, a lot of times, right? And then there, of course, is redox. And that's where oxidation numbers do change. And so that leads us to the next question. What is an oxidation number? Now, this is a way humans, this is how we do it. Right? We actually don't see the atoms and the electrons, right? We can't see it. But we keep track of it with this system of oxidation numbers, right? And so if you look at sodium here, right? Sodium, we know sodium has, right, number 11, so it has 11 protons. And it also has 11 electrons. If we look at the other side of the equation, we still have 11 protons, but now we have 10 electrons for sodium ion, right? Because there's one more positive than negative. Okay. Well, the oxidation state of sodium is 0 here, of course, and it's +1 with the charge. It's +1 for sodium ion. Right? And so if we go from 11 electrons to 10 electrons, we lost an electron. Right? And so we lost an electron. We call that oxidation. So that's oxidation. Now, that electron can't just disappear. It has to go somewhere. Where does it go? Right? Well, that's not so clear. The only thing is, I noticed that hydrogen down here is 0, right? Because why is it 0? It's got 1 proton and 1 electron. So there's each hydrogen has its proton and its electron. But if we look at water, we'll learn in a second that hydrogen's +1, all right? And so here, we gain electron, and that's reduction. All right? And that's what happens with H2. So that's not as clear, all right? And so there are some rules, some guidelines we're going to do to make sure that we have a very systematic way of figuring out what is going on with this, all right? Because, again, the element by itself and the ion, which are the first two rules, are pretty straightforward, but then it gets kind of complicated. Although, you kind of already know these rules. We're just going to put them in order. So rule number 1. An element by itself is 0. Right? That was just like we had. We have, if you have Fe, right, you had Na, we just did F2, O2, Ag, etc. All elements, they have the same number of protons as they do electrons. Neutral atom. So the oxidation state is 0. That makes a lot of sense. Rule number 2, monatomic ions ion equals the charge. All right, so we just had Fe plus, or 2 plus, let's go with 2 plus, Na plus, O2 minus, right? I don't know, K plus, whatever they are, right? Whatever those are, those charges, that's the oxidation state. All right, up third. Okay. Fluorine is -1 in compounds. Period. The only time fluorine's not -1, that's when fluorine's not -1. F2, fluorine is 0. Every other time you see fluoride, it's -1. Okay. Number 4, oxygen is -2 in compounds. Except, right? Except what? OF2, peroxides, superoxide, right? There's also like the hydroxyl radical, which I'm not going to write down, but those are some examples, right? And we have oxygen here being actually +2 and -1 and -1/2. -1/2. How is -1/2? Well, one of the oxygens is 0 and one of the oxygens is -1. Right? So if we look at O2 minus superoxide, 2, 4, 6, 8, 10, 12, 13. That's in resonance, right? So resonance, it can go, that radical can be on either oxygen. And so since it goes back and forth, right, we just call it -1/2, -1/2. Number 5. The rest of the halogens, Cl, Br, I, are -1 in compounds. Except when paired with fluorine or oxygen. So ClO minus and COCl2. Okay? There's a difference here. Here, chlorine is +2. And here, chlorine is actually minus, quite at the end here, is -1. Right? So when we say paired, I mean, there's just the two atoms. Right? Basically, chlorine, bromine, iodine have to be a central atom for this rule to take effect. If chlorine, bromine, or iodine are terminal atoms, they're going to be -1. All right, 6. Let me put that down. Put it in blue. A central atom. All right, 6. Hydrogen is +1 in compounds with nonmetals, and it can be -1 when paired with a metal. Okay? So hydrogen's +1 most of the time. However, if it's paired with a metal, like sodium hydride, potassium hydride, sodium's going to be -1. And finally, number 7, group 1 is +1. And group 2 is +2 in compounds. Period. No exceptions to that, at least not observed yet. And so, if you ever trying to do this, figure out the oxidation numbers of these elements, and you get down and you see calcium. Well, calcium's in group 2, but you think calcium needs to be either +1 or +3 or something. It is incorrect. Calcium is +2. But no buts, right? Just like the rules at my house, right? Rule number 1, mom's always right. But what if mom's wrong? Rule number 2, if mom is wrong, see rule number 1, right? My kids, they chuckle and everybody laughs, but, right, it's teaching you to listen to your mom. In this case, we're not listening to mom. We're telling you that group 1 is +1 and group 2 is +2. all right, in a compound. Now, if obviously you have like sodium metal, like I have up here, that's not in a compound. That's by itself, right? That's elemental sodium, sodium metal, it's 0. Here's a monatomic ion, all right? And so I got my monatomic ion, sodium's +1, okay? So every time that sodium's not an element by itself, it's going to be +1. Same thing with potassium. Calcium, same thing. Calcium's going to be 0 by itself or +2 in a compound. Now, a little note here. All right, the oxidation number or state on an element in a molecule is the charge the atom would have if the electrons in the bond were assigned to the more electronegative atom. Right? Because we might have a compound, a molecule, that does not have fluorine, oxygen, chlorine, or hydrogen in it. Or if it does, there's other elements, like if I have nitrogen and sulfur and hydrogen and carbon. Like, what's going on here? Right? And so the more electronegative atom gets the electron. All right? If that makes sense to you. Okay? And so we'll do some examples. Now, how I like to do this. If I have X, Y, well, let's not do Y, Y. There's an actual X, Z, right? Up here are my oxidation numbers, right? And they add up to the charge. But I need down here my math help, which actually adds up to the charge. What do I mean? Okay. Let's start with magnesium phosphide, right? Now that's a binary ionic compound, right? We're starting right here, and we know if we were doing this, you knew magnesium was +2 and phosphorus is -3, right? We knew that, and we crossed the charges, okay? But if we follow the rules, I put my math help down here first, right? And the charge on this thing is 0. It's neutral, so that has to equal 0. All right, and so I go through the rules. Element by itself, no. Monatomic ion, no. Fluorine, no. Oxygen, no. Rest of the halogens, no. Hydrogen, no. Group 1, no. Group 2, yes. Group 2 metal is +2. All right? And since there are 3 of them, then we have a +6 here. That means underneath phosphorus is -6. So +6 minus 6 is 0. And since there's 2 phosphoruses, we're going to say that phosphorus is -3, which is what it is, right? It's in group 15. All right? Now, 2 minus 3 does not equal 0. However, 6 minus 6 does equal 0. So I use that blue math help to help us with the math that we don't do in our head. All right? Because sometimes it's just easier to write it out. What numbers do I care about? These are my answers. Okay? The bottom is just the math help. I don't need the blue. But I would encourage you to do the blue just because it helps us. Now let's look at the next one. Permanganate. We know it equals -1 because that's the charge. All right, element by itself, no. Monatomic ion, no. Fluorine, no. Oxygen, yes. Oxygen we have. Oxygen is -2. And there are 4 oxygens, so 2 times 4, -8. So what has to go underneath manganese? Well, what -8 is -1? I think +7 is. So manganese is 7. All right, so hopefully this is now why you're seeing I'm doing the math help. okay? Because 7 minus 2 does not equal negative 1, but 7 minus 8 does. All right, chlorite. Here we go. We add up to the charge of negative 1. All right, so we go through the list. Element by itself, no. Monatomic ion, no. Fluorine, no. Oxygen, yes. So oxygen is minus 2, and there are 4 of them, so that's a minus 4. So that means, what does chlorine have to be? Well, it looks like it has to be plus 3, doesn't it? All right, so chlorine is plus 3, oxygen is minus 2. Bromine trifluoride. Add up to 0. What would we start with? Element by itself, no. Monatomic ion, no. Fluorine, yes. Fluorine is minus 1. And there are 3 of them, so that's a minus 3. So it looks like bromine has to be plus 3. XeOF4. All right. And so we look at this. We add up to 0. Go through the list. You get fluorine first. Fluorine's minus 1. There are 4 of them, so that's a minus 4. Then oxygen. So oxygen is next at minus 2. And that's another minus 2. So that means this xenon has to be, looks like, plus 6 to make this work. All right. There we go, right? So like OF2, oxygen is paired with fluorine. Here, oxygen is not paired with fluorine. There's 3 elements. All right, sulfate. We add up to negative 2 on sulfate. You start with, right? Usually now we realize I'm starting with oxygen because there's no fluorine. And so there's minus 2. That's a minus 8. So that means sulfur has to be plus 6. And finally, calcium hydride. You see calcium, you can just write plus 2 here because it's a group 2 metal. All right, we do the math though, 0. All right, we know this is plus 2, and so this has to be minus 2. Each hydrogen is minus 1. So when hydrogen's written second, it's, with a metal like this, it's probably going to be negative 1. All right, so why are we doing this? This seems kind of boring. All right, because we got to figure out where electrons are going to and from. I mean, think about how many things you have that have batteries that use electron transfer reactions. There's a lot. It's kind of important to have, right? Okay, and so we talk about these oxidation reduction reactions. We want to be able to eventually, in Chem 2 we do this, we harness the electricity to do work, right? Just like, a cell phone, a flashlight, tablet, computers. All right, so now, oxidation, the loss of electrons, right, is oxidation. Is always balanced by the reduction, the gain of electrons. Think of oxidation as kind of like a sign oxygen was here, right? Because that's the number 1 oxidizer in our Earth. All right, so we have an example. Magnesium plus carbon dioxide going to magnesium oxide and carbon. I want to know who's oxidized. Well, my recommendation is do the oxidation states. We're in Chem 1. There's other tricks to use, like if you either gain or lose hydrogen or gain or lose oxygen. I don't want you guys to memorize that. I want you guys getting the oxidation states first. And so first, magnesium, pretty straightforward, that's 0, right? And carbon on the end is 0 because they're elements by themselves. All right, the easier one is probably the product of magnesium oxide because magnesium is plus 2 and oxygen is minus 2, right? Because that's a binary ionic compound. Magnesium oxide, those charges are the same as the oxidation states. Carbon dioxide is the different one. We know it adds up to 0. You follow the rules, oxygen is minus 2. And there are 2 of them, so it's a minus 4. So I mean carbon has to be plus 4 here. All right, so who is oxidized? Who loses electrons? All right, that's a good question. And so the element oxidized, I think, would be magnesium. And if you need to do this, magnesium, 12 protons, 12 protons. Magnesium here, 12 electrons, and here, 10 electrons. So oxidized, right, would be Mg. It goes from Mg0 to Mg2+. Reduced. Well, I go from carbon in carbon dioxide at +4 to carbon by itself. So reduced looks like it's carbon. C4 plus going to C0. All right, now elements get oxidized and reduced, but substances, it can be an element, but substances are the agents. So what substance is doing the oxidation? That substance is CO2. And what substance is doing the reduction? Mg. All right? So carbon dioxide is the oxidizing agent. It causes the oxidation to occur. Magnesium is the reducing agent. It causes the reduction to occur. All right. So now, a little bit more practice. I want you to pause me, try to do this real quick, and then catch back up. All right? So hopefully you pause me, and let's go through this. All right, math help for this, 0. Start with oxygen, -2. All right, and so we have -8. Hydrogen's +1, right? It's either going to be +1 or -1. +1, so that's a +1. So chlorine's +7. E, I'm going to go across, then down. So I'm not going to go down, then across. I'm going to go across, then down. So I'm going to do E next. And if you name that, that's iron 3 hydroxide, right? So those charges in that binary ionic compound are the oxidation states. If you did the math, you get a +6 here and a -6 there. It works, but that's what it is. Now, what's interesting about calcium nitrate. Nitrate's nitrate, right? You can actually take nitrate up here, NO3-, and do nitrate by itself. All right, so oxygen's -2, -6, +5. You can do it by itself because nitrate's always going to be that way. There's never a nitrate that's not that way. All right, and you know that calcium's +2 because that's what it is. All right, so nitrogen's +5, oxygen's -3. Let's see, does that actually work? So I got 2 here. 5 times 2 is +10. 2 times 3 is 6. Times 2 is -12, right? I think that works, right? So you can always do the polyatomic ions by itself. You don't have to. Sometimes you can figure it out, but sometimes you can't. Phosphate, add up to -3. I start with oxygen, is a -2, -8 there. So that's +5, isn't it? We got O2, element by itself. Nice. J, well, the name of that would be nickel what oxide? Oxygen's -2, so nickel 2 oxide. BrO3-, another polyatomic ion. Adds up to -1. Start with oxygen. Oxygen's -2. That's a -6, so that means bromine's +5. Iron 3+. Easy. Don't need to circle it. All right, naming of K. That's vanadium and sulfate. Sulfate is -2, and there's 2 of them, so that's vanadium 4 sulfate. Okay. But let's just say you didn't know that. You could always do SO4 2- like this. We just did this one, -2. Oxygen was -2, which is a -8 +6. All right. And so plus 6 minus 2 equals 0. So 6, that's plus 12. 8 minus 16. So yeah, it has to be a plus 4. How about that? It works out. All right, again, so however you're attacking those, because that's technically a binary ionic compound. However you're attacking it, I'm happy with, as long as you're doing it right and consistently. Dichromate. We add up to -2. Got oxygen. Oxygen is -2. And there's 7 of them. That's -14. So we have to have plus 12 here. So each chromium is plus 6. Sodium hydride. +1 and -1. Oxygen difluoride. Oxygen is, we don't start with oxygen. We start with fluorine. It's -1. Be careful with that. So if you need to do the whole thing, feel free to do the whole is an element by itself, monatomic ion, right? Then fluorine. All right, so those are oxidation states. Hopefully we're getting comfortable with this. All right. Now, here, I want to know which ones of these are oxidation reduction reactions, and if they are, all right, identify the oxidizing agent, reducing agent, substance being oxidized, substance being reduced. Is a redox? Well, if you look, all right, if you look here, I have copper going to copper 2, and I have silver plus going to silver, right? And so it looks like I have a reduction here, and that probably means this is an oxidation. All right, so how did I know that so fast? Well, 0 plus 1, 0 plus 2. So their oxidation states change. Now they're either element by themselves or monatomic ions. So that's an easy one to start. B, the next one, HCl. Well, what's our oxidation states? All right, we got +1 for H, -1 for Cl, -3 plus 1. All right, what happens here? Chlorine -1. Hydrogen's +1, +4, -3. That work? Yeah. Nobody changed. So B is not redox. All right. I just realized in A we didn't do everything. So we identify oxidizing agent. Which one is the oxidizing agent? Ag plus is ox agent, and Cu is your reducing agent. Okay. C, what do we have here? Well, we'll have to look at everything. All right. So we look. All right. So oxygen's going to be -2, and there's 4 of them. That's -8. We have 4 at +1, so it's +4. So that means this is +3. So aluminum's +3. That's what we expect. Here, -1. We got -2, -4, +3. Aluminum doesn't change, and yeah, this is not redox. All right, not a redox reaction. D. Ooh. One thing you can look at. I have nitrate here, right? Do you think nitrate changes its oxidation states? Nope. And what do you notice here? I have silver by itself, and then silver with something. Then I have copper by itself, and copper with something. Ooh. So if nitrate is -1, I think silver is +1 here, and I think silver is 0 there. And then same thing with copper. Copper is 0 here, and there's 2 nitrates, so it's plus 2. So who is oxidized? Copper's oxidized, that means reduced, is silver. All right, who is my oxidizing agent? Silver. And Cu is my reducing agent. In fact, you might recognize A. This D is the balanced chemical equation. A is the net ionic equation of D. All right, last one here. H plus 1. Right, we know plus 1 minus 2. Plus -2, so that's a minus 2. 4 minus 8 plus 6. Minus 2, we just did this one. Minus 2 minus 14 plus 12 plus 6. This is acid base. That's not redox. All right. Boom. One more. I think this is our last problem. Oh, I didn't do not disturb. All right. So our last problem here. We have sodium, oxygen. So sodium is 0. Oxygen is 0. Sodium is going to be plus 1 in compound. Oxygen is minus 2. And that works out, right? And it's balanced. I want redox reaction. All right. So what is a redox reaction? All right. This is electron transfer reaction. So electron. Now, where are the electrons going? Again, I have 11 protons and 11 protons. 10 or 11 electrons and 10 electrons. Right? And so electron transfer, right? Electrons from sodium to oxygen. Half reaction. All right, so this is the two things. Right? Who is being oxidized or reduced? Well, oxygen reduced is O2 gaining some electrons going to O. Right? Okay, so the half reaction here, this is a half reaction. So there's actually O2, and it's actually going to be 4 electrons, and there's 2 O's. Because I'm going to put Na in parentheses there, O, right? Why are there 4 electrons? Now, I'm not going to be big on this, but why are there 4 electrons? Well, each oxygen goes and gains 2, right? We go from 0 to minus 2. So oxygen needs to gain 2 electrons. But there are 2 oxygens. So each oxygen gains 2 electrons, so 2 to 2 is 4 electrons. The oxidation one is Na, 4 of them, going to 2 Na2O plus. Well, not like I don't want to really do that. I want to just want to do this. Na going to Na plus an electron. And you have to times that by 4. All right. I don't like the reduced one because that's not exactly how it works. But that's okay. It's close enough. So that means, what is the oxidizing agent? O2 is the oxidizing agent, right? So O2 is the oxidizing agent. If I can spell today. Taking electrons from sodium. And A is the reducing agent. Taking electrons, or giving, not taking, giving, holy cow, giving 2O. All right, and so let's recap. Have 4 sodiums that give 4 electrons to oxygen, all right, to make sodium oxide. And so my reducing O2 plus 4 electrons going to 2 O's. We can probably let's just erase these NAs. All right, 2 O's that are 2 minus. And then our oxidation, we have 4 sodiums going to 4 sodium ions plus 4 electrons. These have to be the same, all right? Now, that's more of a Chem 2 with me, but they have to be the same. So if this comes up on the homework, that's what we're talking about. And then, so these are both, and I'll write these down, these are both half reactions. Why are they half? Well, it's half the electron transfer. So you either had the oxidation half or the reduction half. Those are their half reactions. All right. And so then if we go from there, what else? I think that's it. So oxidation states are big. Can you find them? Can you see what element is being oxidized, what element is being reduced? Those are the 2 big takeaways from electron transfer reactions in Chem 1. Hopefully that works for you guys. If you have questions, reach out, and we'll see you next time. All right? Take care.